Hello students, today we are going to study very important section vector, that is questions based on parallelogram law of vector addition and important results, as well as vector multiplication, that is scalar product and vector product. Okay, let's start. This is parallelogram law of vector addition. With the help of this law, we will be adding the vector, two vectors. Along with addition, we will be finding the resultant value and angle made by the resultant with some particular vector. Okay, let's see. Dear student, let us assume here are two vectors P and Q, which are inclined at an angle theta. Okay. Now, what we are interested in finding the resultant of P and Q, and also we are interested in finding the angle made by the resultant with vector P or vector Q. Okay. Now let's see. Let us mark this vector to be P vector or this vector to be Q vector. Now what we are doing, why this law is called parallelogram law? Because here parallelogram is formed. Okay, just shift this vector. Shift this vector. How the vector is shifted? Parallel. Okay. So we are shifting vector Q. Since this vector and this vector is parallel, so what? This angle is theta. This is also theta. So this is here parallelogram is getting formed. Okay. So dear student, what is the resultant of P and Q? This is the resultant. Okay. This is the resultant of vector P and vector Q. Let us assume this resultant makes angle alpha with vector P. Okay. Now for finding the resultant value, what we are doing? We are making the vector component of vector Q. And we already know how to make the vector component. Just drop the perpendicular. Okay. Let us assume this at point N, this is at 90 degree. Okay. Suppose this is point A, this is point B, this is point C. Okay. Now ANC is a right angle triangle. ANC is a right angle triangle. In right angle triangle, we can use Pythagoras theorem. Hypotenuse square equal to base square plus perpendicular square. So what we will get? AC square equal to N square plus CN square. And what is N? N equal to AB plus BN. Okay. So let's write the equation and find the result. So AC square equal to N square plus Cn square. We will get, what is N? AB plus BN plus Cn square. So dear student, in vector form this is R square and this is P plus Q cos theta and this is Q sin theta. This will become P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta, and finally we will get R equal to under root P square plus Q square plus 2PQ cos theta. This is the final result. Okay. This is the final equation, okay, of the resultant of vector P and vector Q. If we are interested in finding the angle made by resultant with vector P, this is alpha. So tan alpha in this triangle NC, tan alpha equal to what? NC upon N. So tan alpha equal to what? Q sin theta upon P plus Q cos theta. Okay. So dear student, we can write tan alpha equal to Q sin theta divided by P plus Q cos theta. This is the value of the resultant. Okay. Now, based on these two equations, we will be writing some important results. Okay, let's start. If angle between two vectors is 0 degree, means vectors are parallel. Dear student, cos 0 equal to 1. When vectors are parallel, resultant will have maximum value. So R will be equal to P plus Q. Okay. So in this situation, resultant will be maximum. This is equal to P plus Q. Okay. So whenever you need to find the maximum value, you take parallel vector. Okay. If theta equal to 180 degree, means vectors are anti-parallel. So dear student, what you will get? Resultant will have minimum value. This is equal to P minus Q mod. Okay. So resultant of P and Q can have value between P minus Q to P plus Q. Okay. Now, this third result is also very important result when there are two vectors of same magnitude. If there are two vectors of same magnitude, dear student, resultant will always pass through their angular bisector. Okay. When there are two vectors of same magnitude, resultant will always pass through their angular bisector. Okay. What is meaning of angular bisector? If the angle between two vectors is theta, then the resultant will pass at angle theta by 2. Means if the angle between P and Q is 90 degree, resultant will pass at 45 degree. If angle between P and Q is 120 degree, resultant will pass at 60 degree. If angle between P and Q is 60 degree, resultant will be at 30 degree. Okay. So you can understand where the resultant will be. Now, dear student, I am telling you two more important results. If two vectors are of same magnitude and angle between the vector is 120 degree, cos 120 degree equal to minus 1 upon 2, then resultant will be equal to magnitude of any one vector. Okay. Now let's see the fourth important result. All these results have been derived from these two equations. Okay. So if P equal to Q and theta equal to 120 degree, then dear student, R will be equal to P. Okay. Now let's see, if P equal to Q and theta equal to 60 degree, dear student, cos 60 is 1 by 2. So R is equal to P root 3. And dear student, if P equal to Q and theta equal to 90 degree, then resultant will be equal to P root 2. All these are very, very important results which you can apply in any vector question, vector numerical problems. Okay. To make the problem to be very easy. Okay. Now, dear student, we will be looking for vector multiplication. In vector multiplication, we study two type of vector multiplication. First is scalar or dot product of two vector, and second is vector or cross product of two vector. Okay. So let's start vector multiplication. Vector multiplication is of two types. First is scalar or dot product of two vector, and second is vector or cross product of two vectors. Why this is called scalar product? Because the multiplication of two vectors gives us scalar quantity. And why this is called vector product? Because multiplication of two vector gives us vector quantity. Okay. Now, dear student, let's see scalar or dot product of two vector. Scalar or dot product of two vectors. It is named as dot product because it is represented by dot. Okay. It is named as scalar product because multiplication of two vector quantity gives us scalar quantity. Okay. So, dear student, the scalar product of two vector is given as A vector dot B vector. The solution of A dot B is given as magnitude of vector A, magnitude of vector B multiplied by cos theta. Theta is the angle between vector A and vector B. Okay. So this can be written as AB cos theta. Dear student, this is A dot B. Now solution of this. Now there are many results based on this result. Okay. A dot B equal to AB cos theta. Look here, important results. If I cap, j cap and k cap are unit vectors along x, y and z directions respectively, okay? So I cap dot I cap will be 1 because magnitude of unit vector is 1 and angle between I cap and I cap is 0 degree, cos 0 degree equal to 1. So I cap dot I cap equal to 1. In a very similar way, j cap dot j cap is also 1. In a very similar way, k cap dot k cap is also 1. Dear student, angle between I cap and j cap is 90 degree because I cap is unit vector along x direction and j cap is unit vector along y direction. The angle between x direction and y direction is 90 degrees. So dear student, I cap dot j cap will be 0 and j cap dot k cap will also be 0 and I cap dot k cap will also be 0. Okay, hope you understood. So what you are getting? You are getting I cap dot j cap equal to 0. J cap dot k cap equal to 0. K cap dot I cap equal to 0. Okay. So let's write this important result. I cap dot I cap equal to j cap dot j cap equal to k cap dot k cap equal to 1 and I cap dot j cap equal to k cap dot k cap equal to k cap dot I cap equal to 0. Now look at the second result. The dot product obeys commutative law. A dot B is equal to B dot A. Why? Because cos minus theta is cos theta. So dear student, dot product of two vector obeys commutative law. Dot product of two vector obeys commutative law. Okay. Now let's find angle between two vector. And magnitude of a vector. Magnitude of a vector. Dear student, magnitude of any vector A equal to A1 I cap plus A2 J cap plus A3 k cap can be found. Magnitude of any vector is equal to square root of self dot product of two vector and can be written as square of coefficient and then add a1 square plus a2 square plus a3 square and take the under root. Okay, this is the magnitude. Now dear student, let's see the angle between two vector. Fourth important result, finding angle between two vectors. Since we know A dot B equal to what? AB cos theta. So cos theta will be equal to what? A dot B divided by AB. Cos theta can be written as A dot B divided by magnitude of A and magnitude of B. In this way, we can find the angle between two vector. Theta equal to what? Cos inverse A dot B divided by magnitude of vector A and magnitude of vector B. Okay. In this way, we can find the angle between two vectors. Now, dear student, if two non-zero vector, listen very carefully. We are talking for non-zero vector. If two non-zero vectors are perpendicular to each other, if two non-zero vectors are perpendicular to each other, then essential condition is that their dot product must be equal to 0. And vice versa, if dot product of two non-zero vectors is 0, then vectors will be perpendicular to each other. Okay. Condition for two non-zero vector to be perpendicular to each other is that their dot product must be equal to 0 and vice versa. If dot product of two non-zero vector is 0, then vectors will be perpendicular. If vectors are perpendicular, then dot product of two non-zero vector will be 0. Okay. This is very important result. Now let's find the projection. Projection of vector A along vector B. Now dear student, we are finding very special case. Projection of vector A along vector B. Let us assume angle between two vectors is theta. So make the component of vector A along vector B. This is what? This is A cos theta. So projection of vector A along vector B is component of vector A along vector B multiplied by unit vector in the direction of vector B. Okay, this is the projection of vector A along vector B. And what we can write here? We can write here A cos theta into B vector divided by magnitude of B vector. Or we can write here multiply this AB cos theta into B vector multiplied by B square. And this can be written as A dot B vector divided by B square. Okay, so this is what? This is the projection of vector A along vector B. This is the projection of vector A along vector B. In a very similar way, you can find the projection of vector B along vector A. That will come A dot B, A vector upon A square. Okay. Now you can solve any problem by using all these. You can solve any problem by using all these concepts. Okay. Understood. Okay. Now, dear students, we will be looking for cross product or vector product of two vectors. Cross product for vector product of two vectors. Now, dear student, we are looking for cross product. Okay, what is cross product? How the cross product is defined? The cross product of two vector A and B is defined as magnitude of vector A multiplied by magnitude of vector B multiplied by sine theta into n cap. Here n cap is a unit vector that indicates the direction of A cross B. This AB sine theta is the magnitude of A cross B. Any vector can be written as magnitude of vector multiplied by unit vector. So dear student, this n cap indicates the direction of A cross B, means n cap is parallel to A cross B. Okay. And direction of n cap, here direction of n cap remains perpendicular to direction of vector A and perpendicular to direction of vector B. Okay. Dear student, n cap remains perpendicular to vector A and n cap remains perpendicular to direction of vector B. Dear student, how the cross product can be represented? Keep the right hand fingers. The direction of n cap can be given by right hand rule. Okay. Keep the right hand fingers in the direction of vector A and curl them in the direction of vector B. Suppose vector B is here upside. Then direction in which thumb points. Then the direction in which thumb points is the direction of n cap. Okay. Dear student, vector product do not obey commutative law like scalar product. Vector product do not obey commutative law, means A cross B will not be equal to B cross A. Though their magnitude are same, A cross B and B cross A are same in magnitude, but they are not in same in direction. They are anti-parallel to each other. Okay. So dear student, let's write some important property, okay, of vector product. Results. A cross B is not equal to B cross A. A cross B and B cross A have same magnitude, but they are anti-parallel. A cross B is equal to minus B cross A. Now look at the second result. Dear student, if we are interested in finding the unit vector perpendicular to plane of both vector A and vector B, then this is the equation. N cap equal to A cross B divided by magnitude of A cross B. Okay. This is the unit vector perpendicular to plane of both vector A and vector B. Okay. If they are perpendicular means we can write indirectly n cap dot A cap. This will be 0. N cap dot B cap. This will also be 0. Okay. But in vector multiplication, it is not necessary that A vector and B vector are also perpendicular. Okay. Now let's see third result. Okay. That is also very important result. If this is I cap, this is J cap and this is K cap. Dear student, I cap cross J cap equal to K cap. J cap cross K cap equal to I cap and k cap dot cross I cap equal to j cap. In a very similar way, j cross I is minus k cross j is minus I, and I cross k is minus j, and I cross I equal to j cross j equal to k cross k all equal to 0. Okay. Now, dear student, how to find the cross product? Let's see fourth result. Suppose this is vector A1 I cap plus A2 j cap plus A3 k cap, and this is vector B1 I cap plus B2 j cap plus B3 k cap. Okay. Now we are interested in finding A cross B. Okay. So either we can directly multiply without changing the order, or we can use determinant method used in mathematics like this. This is I cap and this is j cap and this is k cap. Put the coefficient of I cap, j cap and k cap. First put the coefficient of vector A, that is A1, A2 and A3. Then B1, B2 and B3. Now we are using solution of the determinant. Okay. I cap, we are writing cofactors. This is A2, A3, then B2, B3. Minus j cap, this is A1, A3 and B1, B3. Plus k cap, this is A1, A2 and B1, B2. The solution of this determinant comes as A2, B3 minus A3, B2. I cap A2, B3 minus A3, B2 minus j cap A1, B3 minus A3, B1 plus k cap A1, B2 minus A2, B1. Okay, this is A cross B. Dear student, this is the process by which A cross B is determined. Okay. Now, we will be looking for some more important result. Let's see now. Suppose this is a parallelogram whose adjacent sides are represented by two vectors A and B. Then area of parallelogram can be written as A cross B. In case, in equation, if equation of diagonal is given, suppose this is vector C and this is vector D, then area of parallelogram in this case equal to C cross D divided by 2. Okay. If we write the area of triangle, if we write the area of triangle, if we write the area of triangle having adjacent side is vector A and B, so we can write half A cross B. A vector and B vector are the adjacent side of a triangle. Okay, in that way we can find the area of triangle. Okay, so this is the result number 7. Now if we are interested in finding the volume of a parallelepiped, then we can write A cross B. These are two adjacent side and this is height. A cross B dot H. Okay, this is the volume. And dear student, now I am telling one very important result, that is Lamy theorem. If a body is in equilibrium and three forces are acting at a point, let us assume F1, F2 and F3 are the three forces acting at a point at angle alpha, this is beta and this is gamma. Then if the body is in equilibrium, then we can write F1 upon sine alpha equal to F2 upon sine beta equal to F3 upon sine gamma. This is the equation in equilibrium. Okay, this is called Lamy theorem. Okay, so dear student, this was all about the vector concept. In the next lecture we will be seeing the vector problems. Okay, thank you very much.